Hello, hi everyone. All right, waiting for some more people to join. Hello. All right, so just going to wait for 2 more minutes for some more people to join. All right, thanks everyone for joining. We're just going to start now. 2 hours workshop. Let's see how much we can do. All right. As usual, we have the repo up in our Nella Labs GitHub. I'm going to copy and paste the link into the chat function here, so everyone knows where the repo is. All right. Okay. Okay, pasted the link to the repo in this chat function. So everyone can just go in and clone the repo, open your own IDE. So I'll just give everyone some time to do this. Anyone not sure about like how GitHub works or cloning, just let me know as well. All right, so hope everyone has already cloned the repo. If you haven't, or anyone new joining, if you didn't get the repo link, just tell us in the chat function. I'll just share the link again. All right, I'll share my screen, and so you can see my IDE. All right, if you can't see my screen, just let me know. Okay. All right. Awesome. All right. So I'm just going to open the README file. So what we need to know, an overview of what we're going to cover today is all inside this README file. All right. So tool calling. Tool calling is a fundamental part of agentic AI, something that we all need to know if we're doing something about agentic AI in our projects. But apart from like all the fancy names, you know, like LangChain, LangGraph, um, OpenClaw, right? The skills. We get rid of all those big names and we go down to the very basics of what it means to do tool calling. So in this workshop, right, we're going to write out our own tools and then send to an LLM to do the reasoning and then choose the tool and execute the tool. So I'll explain that further later on. Let's just go through this README file first. So to understand what we're going to do later, well, it will be good to have like some knowledge of how TypeScript works or JavaScript. But then if you don't, I'll just keep on like sharing as well along the way, any lines that we come across, and definitely also async functions. All right, and then for API key, I think I'll just make this larger if it's too small in the share screen. Oh, okay. Yeah, so for API key, I'll give everyone access to my own API key, Mistral. So I'll be using Mistral for this workshop, but feel free to change to your own API key if you have. The repo, right? The whole repo is configured for Mistral. So, but it's just like some files. I mean, the whole repo is structured such that there are um, separate files for the different sections of the content. So you can just change the name of your LLM for the API key where relevant. So you don't need to change everything inside the repo. Yeah, but I'll just provide access to my Mistral API key later on. All right, so the same routine as well. Dependencies need to be installed. So in your terminal, just run npm install, right? So just a quick look through, right? Oops. Just a quick look through of the packages that we have, right? Package.json. All right. So definitely, as you can see here, we have TypeScript and TS node. Oh yeah, by the way, so continuing from what we had in the LangGraph series, we'll be doing TypeScript as well for this workshop because it's the standard for like full stack applications. If if you prefer Python, Python is usually more for like data science, for academia research, so side projects. I mean, it's also a good language to get used to as well when it comes to doing agentic projects. But for this workshop, just for our side, we'll be using TypeScript, right? And then TS node for the quick running of specific TypeScript files. Definitely the OpenAI SDK as well for calling our LLMs. Okay, and then also the package log JSON. Right. I think most of the packages here, we do need to know in detail. Let me see if there's anything in particular. ES syntax. Okay. All right. So nothing important to know in the packages. So just make sure that we install, right, these dependencies. npm install. Okay, so just run this inside of terminal. All right. I'll just go to the chat function whenever I can to see if there are any messages inside. Feel free to message. Let us know if there are any issues. Right, so npm install the dependencies. And definitely, same routine again, to put in our API key for the LLM, copy the environment file, right? Make it an actual .env file. So, right, .env.example. Right, so as mentioned, I'm using Mistral API key. I'm going to give the Mistral API key now. I'll put inside the chat function. Repo. Oh, okay, cool. Thanks, Joshua. Yeah. Uh, yeah, I shared the repo link. I think, yeah, we started earlier lah, but all good now. All right, so I just shared the API key to Mistral. So this will just be used for this workshop. I'll just remove it after this. So yeah, feel free to play around with it for the time being. If you want to use your own API key, feel free to just configure the API key. Okay, where were we? All right. Yeah, so FYI as well, if anyone's new to like env files, so environment variables, right? They are basically all these variables that will be used across your repo. they contain like secrets, right? Important secrets that you can't share with anyone else, right? So must be kept private. So that's why in this .gitignore file, we are also ignoring the .env file, right? We don't want to push this to GitHub. That's why like we only put the API key in this .env file. The example file is just to tell users of your repo, right? Other people who clone your repo, what are the API keys needed. So these API keys are needed to call third-party LLMs. Unless you are using your own model, locally hosted model like Ollama, you put inside your own laptop, then yeah, you do need API keys. Yeah, but Ollama, in fact, yeah, just a quick sneak peek. We'll be doing a workshop on Ollama as well in the coming weeks. Yeah, but not now. Yeah, so just doing like more stuff first about agentic applications. Yeah, so just put in the API key for Mistral. Okay. And we go back to the README file. Right, so that's the copy the environment config. Okay, let's cover what we're going to do today. So we're going to cover the fundamentals of tool calling. We'll write out our own tools, and that means writing out the tool schema. We'll find out more about what a tool schema is and what a registry is. And then once we have the tools, okay, I feel like it's kind of, never mind. I'll just give a quick overview of all these four parts. So we have tools for the LM. We write out the tools. Tools are actually functions, right? Don't think about the big names, LangChain, LangGraph, N8N. You go down to the first principles, right? Just like what Elon Musk says. Think about the first principles. Tools are actually just functions. And if you didn't know what a function is actually just any written program, a file, or like just a few lines of code in a file. A function is just like that. Even just print hello world, right? That popular, the most cliche thing in coding. Think of tools as just functions. You have the functions, you store inside a registry. Think of registry as a database. You register all the tools you want your LM to use. So that LM, right, can just search in this database, this registry, understand what tool you want to use, and then call that tool and run it and give you your output. And once we have this registry, so actually just as mentioned as well, the LM will go through reasoning, right? It's the brain. So think of the tools as the hands. The brain is the LM, brain and hands. The brain needs to reason. The brain will think through, okay, reason through. You have all these tools inside the registry, right? Which tool is the most appropriate one? Which tool is the one that best represents your prompt? When you prompt the LM, when you send the prompt, right, through API over to the LM, it will think through, right, reasoning. And React, by the way, if you didn't come across this word before, this is a framework for agentic AI. This is not the React framework for web development. Yeah. Notice, I think it's quite smart lah. The people who came with this name, right? They make this A, big A, capital A, to differentiate from React JS. So React Native, React JS, FYI, it's like this web development framework. This is very different from this React. This React is for agentic applications. So it's just like a formula, like a principle to follow for developers. So make sure that to get the desired output, right, the LLM must reason, okay? Think through. It's really common sense, actually. It's really common sense. You want your brain to reason, right, to think through your prompt first, break it down, analyze, and then choose the tool to use, right, act. And then observe whether the output is correct or not. And then after that, reasoning and acting. Okay, actually, this acting comes to the next step also. So reasoning, right, choose a tool, and then you orchestrate. So this is the running of the tool. After running the tool, if the user wants to call the tool again and again, or maybe different tools, right? We want context. So this is state persistence. It's just a fancy name for memory lah. You want the LM to remember the whole conversation that you had with the LM. And if this brings any memories, pun intended lah, this was covered lah also in the LangGraph series that we had. And as you can see also, this whole tool calling workshop, this is kind of like continuation as well from LangGraph. LangGraph one, the one that we did earlier, last month, I think, it's more catered towards LangGraph. But then this tool calling part, this one that we're doing today, it's a more general overview of what tool calling is about across LangGraph, across Crew AI, AutoGen, different kinds of agentic frameworks and applications. So we are looking at the bigger picture. And state persistence, right, it's not just specific to LangGraph. Different agentic platforms, they all need state persistence. They all need memory to function well, right? When the user keeps prompting and prompting, the LM must understand the chat history. Okay, so these are the 4 key things that we need for tool calling. Okay, so inside the repo, there's also like a good reference, examples folder to implement tool calling. One is weather agent, another is GitHub search agent. We can look through this after we've gone through the first few parts of this workshop. So this is like the what's that? Like the summary of everything. Implement an actual agent. Okay, TypeScript function. Okay, so we'll go to this file now. All right. Oh wait, yeah, this one. Wait, I'll just change this to. Oh, okay. Right. The folder name changed. All right. Okay. So we'll go to the solutions folder. All right, solutions folder, and part 1, tool schema. So we'll now dive into what it means to write a tool schema. Okay, tool schema.ts file. So for tool schema, if it rings any bell also, previously in the LangGraph workshop, we went through schema for states. And states, right, are basically the input and output format whenever the different functions are called inside the graph. And why was that used, right? The schema was used to structure your questions and answers with the LM, Q&A. You want to make sure that the LM knows what you are saying and you actually understand what the LM is outputting. So same thing here as well. On the more general overview, schemas are also used to structure what tools need to be called. So when we tell the LLM to use a certain tool, we want to structure the definition of the tool. Tell the LLM that this tool, okay, the name is this, the description is this, the arguments you need for this tool to work are this and this and this, right? So everything is properly structured. Then the LLM can understand and reason better, or to even reason at all. Wait, what did I write here? Tool schema domain registration. Okay. Okay, we can go through this as well. All right. So, okay, yeah, we go to this part first. Okay. Oh, tool definition. Interface. Okay. Okay, never mind, sorry. Yeah, so we stay in this toSchema.ts file. And so to define the schema for a tool, basically the structure, the definition of the tool, we write out a JSON. So every tool, right, is just a JSON. JSON basically JavaScript object notation, JSON. So this whole thing here, wait, I'll just zoom out a bit. Oops. Okay, this whole thing here, okay, don't be intimidated by it. Actually, everything is really structured. You can see clearly that it has a structure. This is a JSON. And what it does is it defines what a tool is. And in this case, we are defining a tool to get weather data, right? This is the function name, get weather tool. So as mentioned also, tools are just functions. And we are putting this as a constant, so it will not change. And export. So in TypeScript, JavaScript, we use export and import statements, right? For example, at the top here, import. We're going to look through this later on. This is also quite important. But also, export, import, right? They are used so that functions and variables and objects as well, basically, they can be sent to another file in your repo. So that's the purpose of export and import statements. We put export at front because this tool will be used in another file later. And the type is tool definition. And this whole thing is a JSON. So JSON, right, brace curly brackets. So whenever we give it to the LLM knows that, okay, this type is a function. So that's the kind of like the official name for tool, type function. And then function, a JSON itself from here to here. And in fact, this whole tool, right, there are only two properties, right, type and function. So the LM knows that, okay, the type is function, and the function, the name is a weather tool. And then the description, the LM also knows that, okay, this tool is meant to fetch current weather conditions. So that's the description. Notice that a lot of this, right, is actually just English. And that's the beauty of working with LMs. Right now, a lot of tools, it can just be simple English. And then when you pass to the LM, it will pass your inputs and understand the context of the tool. So name, description, parameters. So parameters are the inputs to the tool for the tool to process and give an output. Right. So also gentle reminder, do not memorize any of these like JSON structures because the way we write these tool definitions, they also differ for different people. This is just one example of a tool definition because this particular definition is used in this repo only. In the other files, when they call this tool, right, they will refer to these specific properties and names, like get weather tool function name, right? So it depends on how you want to write it. So don't memorize the structure. Just understand the flow of it. Understand how a tool definition is defined. And then you have the description of a particular input, which is the location. So weather, right? Weather data, you want to know the location first. The LM needs to know the location where you are talking about to get the weather of that location. So something specific for this tool. And then unit as well, Celsius or Fahrenheit. Enum, by the way, enum is just to list out named constants. So you specify that it has to be either one of the properties, either one of the elements inside this array. So definitely, especially for like temperature degrees, right? It can only be either one, Celsius or Fahrenheit. So this makes it This makes it better for the LM to understand where you are going. So this is a temperature degree value, temperature unit description. Okay, and then required, this specific property is to tell the LM that this specific input location, right, is needed. The user, when they prompt the LM, location must be inside. You do need to specify Celsius or Fahrenheit, but if you want to, you can also put inside required. But location, it's the most important thing, which is also common sense, right? To get, right, for this tool to function, it must know the location. So again, there are only two properties. So just read it based on the indentation, right? So at the very start, there are only description and parameters. And then inside parameters, then only you have all these things, all these subfields. So again, don't memorize the structure. Understand how a tool like this get weather tool is structured. So basically, it's a JSON. This whole thing, the definition is a JSON, fields, and then the values for it. Okay, we'll now look at the tool definition structure. Right, so this is in the types.ts file. And this will be the way that we write out tool definitions. So we store it inside this file so that it can be called in other files as well. All right. So it's here. And it's actually very simple. So this can just be a template. And then further on, we will then abstract different layers of the definition. So for tool definition, interface is actually just a fancy name in TypeScript that it's a class object, a class type. Sorry, object type. So interface is an object type. And we define the tool definition in this way so that all future tools, they will all be defined using two properties, type and function. Like what we saw earlier in the get weather tool, it also has two properties only, which is type and function. So all tools will follow the same structure. And so this is just basic coding as well, right? So for the same object tool, right? For all tools, they follow the same object data type, right? We define it tool definition. And then for tool function, this will relate to another object type that we also define here, which is just above here. So export interface tool function. We define the function field, right? This property inside tool definition to have three properties, right? So they are just sub properties. And just like what we saw earlier in the get weather tool as well. So we just go back, I just go back for a while. The get weather tool function, we see that inside the function property, that is name, that is description, and there's also parameters. Right, three sub-properties. And this follows the structure that we defined in types.ts file, the tool function. So it has three sub-properties, name, description, parameters. And then for parameters, we define yet again a certain structure for this property, two parameters. So also notice at this point, right, that we have different layers of a tool definition because this makes it clear to the LLM what kind of tool this is. All this makes the context for the LLM to understand the tool that it is looking at when we present this tool to the LLM. So depending on the task at hand as well. So some tools, maybe the tool definition that do not need to be this complex, because I do admit this tool, it has different layers. So it will take some time to understand how it works. But this is like the abstraction for multiple tools so that we can create different tools for different purposes. For parameters, so it has its own structure as well, called tool parameters. And where's tool parameters? Just above here. Okay. And it has its own properties, type properties required. All right. I won't go further anymore because it's just layer after layer, right? So just don't memorize all of this. Understand that inside the tool definition, there are different layers of abstraction for the structure of the tool. We need to define the properties of the tool, like description, the name of the tool, and the input parameters, right? This is all just logical flow, right? For example, like get weather tool, right? The input parameters, what are they? You need to give the location to the LLM, then it can run this tool for you, get the weather location. So just think like that. Different properties for tool definition. Okay. Yeah, so by the way as well, just feel free to refer back to the types.ts file anytime the repo is public. So just feel free to explore it after this workshop. Okay, type object. Where were we? Require location. Okay. Right. So this is the whole definition for get weather tool. So the type of this function is a tool definition, right? We are defining the tool, get weather tool. And now we are going to use this tool. How will we use this tool? So we go down. Okay. After we have defined all our tools, right? So for example, the get weather tool, right? One of the tools that we have, after we define tool 1, tool 2, tool 3, tool 4, we will then collect all of them. We combine all tools into one registry. So we're just going to call it very simple, tool registry. So just like what we went through earlier in the README file, think of it just like a database, a spreadsheet, a collection of tools, registry, right? Tool registry. So this is a class. It's not a property, it's not a variable, it's a class. Actually, at this point, I don't know why it's not called interface, but class and interface, sometimes they're interchangeable in TypeScript. I forgot the specific conditions, when to use class and when to use interface, but they are basically all object types. So this is also an object, tool registry. Inside this registry, it is a map. So for those of us here who did computer science or who are still doing computer science at uni, right? So hash map. So there will be keys and values so that it's O1, so time efficiency. It will be fast for searching a particular value. So basically map is just like a geographic map, right? You want to find a location, you want to find something, it's very easy. Just look at it. You can see at one glance. So same thing for encoding, right? A map is used to store values very quickly. Sorry, store values and find them very quickly. So we will put all our tools inside a map. We first declare the map. So this map name is tools. And inside this map, it will all be a collection of these pairs of values, which is string and registered tool. This syntax, right, it's a type parameter syntax. So we are telling TypeScript that this map contains a lot of these pairs of string and registered tool. These are data types So it's just a general description, right? This is a map of string and registered tool pairs. So the key is a string, the value is a registered tool. We will go through this registered tool later. It's just above, but we'll go through this later. And we'll see later on what these two things refer to inside the map. Okay, now for this class, right, tool registry, definitely when we have tool 1, tool 2, tool 3, tool 4, so many tools, right, and we pass it to the LM, right, we can't just pass one by one. So we have a tool registry, and we use this registry to register the different tools. We add, just think of it just like adding. Actually, register is just a fancy name. Add the different tools into this registry, or more specifically, add into the map. So we define a method of the class. Notice that we don't write out what's that again, the word function before that, because this is ES6 syntax. So in TypeScript, it's like a short form, shorthand. It's already common sense to TypeScript that when you write this, it's a function, it's a method inside the class. So we can just define the method register. And what are we inputting inside this function? So whenever we call this, whenever we call this class method, we're going to input two arguments, definition and handler. So tool definition, right, just like what we covered earlier, like the get weather tool. So that is one tool, right? That is one tool definition. We want to add that tool into the tool registry. So we specify the first argument is a tool, or more specifically, the tool definition, right? So this is common sense. We want to add that tool into this registry, right? We want to specify what tool it is that we are adding. So definition. And then second input to the function, handler. So this registry, right, is not just about adding the different tools into like one database, like one collection, but it also tells the LLM that this tool that we have, right, which, like, how are we going to execute it? How are we going to run it? When this tool is chosen by the LLM, okay, this is the one that the user is talking about. We are going to use this tool. How are we going to run this tool? So there's something called handler. So handler is the kind of like the execution engine. It is the thing that the tool uses to run its logic. So for example, get weather tool, right? The tool is just, it's just like, we go back to the tool definition. You have the name, you have the description, and the IM knows the parameters. But then to actually run this function, right, there is another logic that you need inside the code to get the actual weather data. So we have a handler. So that will be the, that will be the second input whenever we add a tool to the registry. And it's an arrow function. Arrow function input the arguments. Right, so this record type, right, this argument is just the input from the user. Unknown because it can be any kind of data type. So we just put unknown. And then the output is a string output from an async operation, asynchronous, meaning later on we will see that because we need to wait for the LM to respond. So it's an async operation. So it wouldn't be immediate. So it's just a promise of an output. So this is just a generic structure for a handler because there are different handler logic for different tools. That's why this is just a general format first to tell this register function that, hey, we are going to input a handler function as well to let the LM know how to deal with this tool. So different handlers, but the same format, right? You have input arguments and then output, a string output. Okay, so definition and handler, we put these two things together into the registry whenever we register a new tool. And then there's no output, it's a void function. Okay, and then now this is where we call the specific property from the tool definition of functional name. So as you can see, actually, when we go back to the, for example, the get weather tool function, right? So it's getting the function name, the tool dot function property dot name, get current weather. So again, right, don't memorize the whole structure because you are in control. You are writing the code, or if you're using a coding agent, right? So everything is dependent on the user, depends on yourself, like how you want to define the tool definition. So in this particular case, the name is under the function property. So we will get the name in this way, get weather tool dot function dot name. So whenever we register a new tool, we call definition dot function dot name, right? Definition is just the tool, right, from the input tool definition. So we assign to a name, which later on we will put inside the registry. Okay, const name is the tool name, and useful error handler as well, in case you have already registered the tool inside the registry. And then this, by the way, is like, it refers to this class, right? Just like in Python, we have self, right? If anyone's familiar with Python, so self. In TypeScript, we say this dot tools. So tools is back to the property here, right? So this is basically, in fact, the only property of the class, right, which is the map, right? That's the name of the map, tools. So this dot tools, right? We check the map whether you have already registered the tool dot has bracket name. So we check by the key, right? So new map string register tool, right? String. This is basically a tool name. So we can now understand actually that this string, right? The first part, the key is just a tool name. The tool name, which is a string. And if the tool isn't registered before, then we set, right? Just like in arrays, right? For arrays, we set new item or get new item. So we set item. We put in the tool into the registry. So the key is the name, and the value is a JSON of these two functions. Sorry, a JSON of the property, a JSON of the object definition and the object handler, right? Two objects in the value. Now at this point, we're going to look at the registered tool data type. So we can see now that this is different from the tool definition. And so you might be wondering, like, why are we having like two different, like somewhat like two definitions, right? So if we go back, the get weather tool, for example, the tool definition is just about the name of the tool, the description of the tool, and the parameters. What are the inputs to this tool for it to run? But then, like what we mentioned just now, it has to be matched to a handler. Every single tool, it needs to be matched to a handler. Handler, right? Just like what the word actually suggests, how to handle the tool. And so we pair. We need a new data type to pair the tool to a handler. So we define a new object interface registered tool. So before a tool gets into the registry, right, it needs to become a registered tool. Actually, I think it's more like it means that when the tool is registered, right, inside the registry, there is already a handler pegged to it, right? So that's why the name is registered tool. So registered tool is actually just two things inside, two properties inside the JSON, right? The first one is just the tool itself, right? Tool definition, the tool itself. And secondly, we have the handler. So really simple, two things only. Inside the registry, every single tool is matched to its handler. So the tool definition, and secondly, the handler. And so that's why inside the map, right, inside the registry, which is a map, basically, there are pairs of, oops, there are pairs of tool definitions and handlers. So the registered tool. Inside the map, there are all these registered tools. But to make it easy to find these tools, right, the key will be the string, which is just the tool name. So that's the register function. All right, I'm just going to stop here for a while. I think like maybe like 3 to 4 minutes for everyone to process it. If there are any questions, feel free to ask in the chat function, Google Meet. Because I also realized that I think from my own experience as well, like attending workshops and also our previous experience, like doing these workshops, I think it's good to like pause sometimes to let everyone to like sink in, understand what's going on before everyone continues, before we continue on, like going deeper. Yeah, so 3 to 4 minutes. I'll just let everyone like just go through on your own inside the repo as well. Yo, Harish, share recording. Yeah, definitely. For Nara Labs, we are recording now even also, as you can see. Yeah, so we record weekly workshops and we put inside a Google Drive and we'll notify inside the WhatsApp chat when the recording is available. Right now we're using Google Drive, but at the request of a company that we previously worked with, we are also exploring the possibility of uploading on YouTube. Yeah. So for now, it's still just Google Drive for now. And e-certificates, no, there are no e-certificates for like workshops like this. We are youth society, so we are not like a company. Yeah. So these workshops are actually all for charity. We are kind of like a charity. We do this for free and it's all voluntary. Yeah. So there are no certificates. All right, 1 more minute to go. Then I'll resume later. Okay, 3 minutes up. Oh, I just saw some more messages. Ask questions not related to this workshop. Not related. Okay, quite interesting. You can always ask us like DM us on WhatsApp after this workshop. We are available on WhatsApp lah. Me and the other committee members. So feel free to just message us. If you're not in the WhatsApp group, just let me know. I'll just share the link to the WhatsApp. Uploading YouTube is free. Yeah, it's free, unlisted or like public. Yeah, that's why like our corporate partner, yeah, they suggested us like we share on YouTube. So we'll see how lah. Awesome. Okay, let's continue. I think 2 hours not enough time for all 4 parts actually. We're still in part 1, but never mind. You guys can just like feel free to look through after this workshop too. Tool schema. All right, where were we? Handler, configure handler. Okay. Tool registry. Okay, yep, we went through the register function. All right. So just a gentle overview again, like where we are going through like this tool registry, the different tools, right? These are all structures, data structures to be passed to the LM for the LM to understand what tools we have so that it can reason and choose the best tool for the user prompt. Right, so we have this tool registry and we register the tools inside the registry. Okay, and then just a useful function as well, helper function, get definitions. So just let the user get all the tools that are available now in the registry. So output is a array of tool definitions, array of tools basically, and then the body is just return array. So from the map, right, this dot tools, we get the values, right? Because a map is just key value pairs, right? So we get the values, which is the registered tools, right? The value is the registered tool, which is itself contains 2 properties, the tool and the handler. We get this registered tool, and then we map. Map is a specific TypeScript function, a really useful function where you can, from each array item, right, you can look through them one by one. And what we do with it is we perform a function on the values. So we define an arrow function for each value inside the map. So for all tools, so T is just an abbreviation, a short form. For all tools, we will get the T dot definition, and we store it inside array. Yep. So we return an array. So this one line, right, is a very compact form of writing code lah. It stores a lot of different logic, different layers of logic inside. Yeah, but along the way, in case anyone isn't familiar with this kind of like logic, yeah, so if you keep getting used to it, this is the best way to write code actually. So everything very compact. Right, so arrow function, we get the definition. So definition, just a quick recap again. It's a property of the value registered tool. So we get the definition and then store all these definitions inside the array. And then we return it to definition array. So in case when the user wants to know like what are the tools right now inside the registry, okay, and this is the fun part. So when we have all these tools inside the registry already, and the LM chooses one, we want to execute the tool. And so we define an execute function. And async, because this is when the LM calls it, right? The LM calls the tool, executes the tool, and because it's API, that's why there will be some latency. It's a third-party LM that we're using, so async. Even though it's not third-party, if you're using Olama, definitely it's always good to consider latency issues. So async operation, asynchronous, basically you call it, right? You call the function, it will take some time to get back to you. So async, execute. So what are the inputs, right? So definitely you when the LM calls the tool, right? it definitely needs to call the name, call the tool by name. So it's a string, like what we saw earlier. And then the arguments to put inside the handler. Right. So just a recap also, these are the arguments to be put into the handler. And the handler is what is used to run the tool. Right. So back to the definition for registered tool, right? The handler, right? We input the arguments of type record. Okay, this is defined in the types TS file. You can check it out later in our free time. So we put in the arguments into the handler. The handler then can be used to run the tool. So we input the name, the arguments for the handler, then the execute function can run. And it returns a promise because async function, and the output is a promise of a string. So to execute the tool, firstly, definitely we get the tool. So just like array methods for map as well, we get the tool from the map. This .tools.get bracket name. Okay, so just get the tool from the map and then store it inside variable tool. Once we have the tool defined already, oh, okay, there's another error handler here. So just in case the tool is not there, right? So if bracket not tool, just to handle the error, then throw new error. Okay, and then tell the user what are the available tools instead. Okay. Right, so we have the tool, then we can return the handler. Right, so to run the tool, right, we have to call the handler. That's why we return tool.handler and then input the arguments from the user input. So just like that, the execute function. Right, so different tools have different handlers. Whenever a tool is called, we call the specific handler for the tool, return tool.handler. All right. And lastly, to wrap up everything inside the class of tool registry, right? We have execute function, we have register function, and we have the property, the whole map defined earlier as well. So lastly, another useful function, check if the tool name, a specific tool, right, is inside the map. So just called has bracket name, right? Name is the tool name, and output Boolean, output type Boolean, and the body just return a Boolean, return this.tools.has bracket name. So just a useful method for any user to check if a particular tool is inside. And that is basically the entire class of tool registry. Okay, now we have different tools. We have one registry. Now, there can also be some useful functions to convert these tools into these registered tools in the registry. Because previously we also saw that, right, the tool, every tool needs a handler. And so we're just going to have a useful function, build tool, to match every tool to their handlers. So it's just a really useful function to convert the tools into these pairs of tool and handler before they are added to the registry. And so input, we have the handler function. Right, so this is the most important thing. So inside this function, we tell the tool what is your handler. And the name, description, parameters, they are all coming from the tool definition. So we have the definition, we have the handler, then we just jumble together, basically mix them up, right? Combine them together to form the registered tool. And then only then it is added into the registry, right? So return, this is the tool definition. So as you can see also, so this follows the tool definition we had earlier. Depends on how you write it. So don't memorize, just understand the flow of it for any tool definition. And then this is the first property definition, second property handler, right? So this is following the registered tool structure, definition and handler, two properties. Handler is config.handler, basically from the input. All right, so just a useful function, convert tool into a registered tool for the registry. Okay, now before we do calling of LMs, we're just going to do it locally without an LM. And you can see that actually for tool calling, it doesn't have to involve an LM. We can also do it with the code itself only. And how we do it, right? Same thing as well. We have the tools, we have the registry, right? We set out the registry first inside this variable registry. And then we have our tool, we build it, right? Pair the tool definition with the handler. So as you can see here, actually, you can just combine everything into one. The tool definition, the first part, right? Because we have the input argument containing the tool definition and also the handler, right? So don't memorize the specific details here. Understand the general structure. So we input the tool definition, we input the handler, right? So how to handle all this information, basically, how to run the tool. For this particular tool, we are building a calculator. So for the handler, we tell it to use the input parameters, right? To just add them together or minus or times or divide, right? X, Y, and operation. So we have definition, we have handler. And then what do we do next? Once we have built the tool, it becomes a registered tool. And then we add it into the registry using the register function, registry.register. And we put in the two inputs required as stated in the structure. Number one is definition. Number two is handler. Now, once we have it inside the registry, then we can use it. So how do we use it? Like the function that we defined just now, execute, right? So it's a method, registry.execute. Right, these are all just print messages. So the method call is here, await registry.execute. Right, so await, right? Await comes with async. Whenever you do an async operation, right, the async function, you call it, we use await to match the async word, right? They come with each other. So await the async operation to finish and return the output. Await registry.execute, and then we want to have the tool name calculate. We pass in the tool calculate. Sorry, we pass in the tool name calculate, and then it will find this tool, right? So the code will find this tool called calculate in the map. If there is this tool called calculate inside the map, then it will run the tool. And how to run the tool? This handler will be passed inside the arguments for the handler. So A is 3, B is 2, and we want to add them together. So this is just the first query, the first user prompt. Second one is divide. So actually, before the user prompt, you can see that there's also like a string of what the user intends to do, 3 plus 2 equal, and 10 divided by 0 equal. This one is actually more for the context. So it's not part of the input to the handler actually, right? So handler is here, the handler inputs are here. This is just a user input string. As you can see above earlier, right? So there's no mention of the user, sorry, there's no mention of the argument being like a string before the handler arguments. So to call the tool, right, we find the name of the tool first, and then we run the handler. So it's all just something extra for the terminal, actually, just the terminal output, right? Console.log, and then we show that we're doing this operation, because this is just returning an answer. Like if this is successful, this whole function will just return the final answer, which in this case is 5. And this one will run the conditional statement, which we also define here, the conditional statement here, right? So divide by 0, definitely, right? It's an error. It's undefined. So it will just return this answer, right? So the string is just for the terminal. And then definitely for the routine as well, right? So when the file is called, then run the file, run this particular function demo, and then catch any errors, if any. Now I'm going to run this file, and you can see that tool calling basically, right? It's actually, it doesn't have to involve AI. Tool calling, just like what its name suggests, you just call the tool and it performs the function. So tools are essentially just functions, but to make it smarter, definitely, to make it more automated, right? In agentic workflows, in B2B enterprises, right? All those like big projects, then that's where the AI comes in. But for the very fundamental level, tool calling actually doesn't need to involve AI. So I'm just going to run the file here, right? So we use npx ts node. So node package execute this TypeScript file, so that we can just bypass the compilation from TypeScript to JavaScript, right? So, and it's just temporary package running, right? So this is how we usually do it to run a TypeScript file, npx ts node, and then run this particular file, tool schema. All right, so you can see once we run the file, right, the demo function, okay, well, it's not sent to LLM, right? So we haven't configured this to be sent to LLM. It's all just inside the code. So it printed the registry, right? So this line here, line 217, console.log json.stringify bracket registry.get definitions. So we have a line here, especially to let us know that the registry successfully added the calculate tool, right? So before this line, right, we see here registry.register. We had a method called, right, register method. We wanted to register the new tool that we had, right, calculate tool. We want to add it into the registry. And when we print the registry, we can see that the tool was successfully added. So like what we saw earlier, it would print an array, right, array of the tool definitions. So square bracket, array of the tools. So every single tool, like what we saw earlier as well. So you can see now everything just coming together into one picture. So every single tool is a JSON, right? So don't need to think that complex. Every single tool is a function, is a JSON. So this is the first tool and the only tool because we only added calculate tool, right? So curly bracket, type, right? Again, what we saw earlier as well. For the tool definition, we have two properties, right? Very simple. Two properties. Type is function. Second property, function. And yeah, this is where all the layers come in. Name, description, parameters. All right, so don't need to memorize this. So we see that this is the tool successfully added to the registry. Okay, we can skip all this. And now tool execution. Right, so we come here, we inputted two user inputs. And so it worked just as expected, right? 3 plus 2 equals to 5, right? So it understands this as a plus operation. So inside the calculate tool, right, in the handler, right, the handler function, we specify that when the query string talks about add, right, it is a plus function, x plus y. And what is this x plus y? It's from the user input as well. We pass it. It is the first two inputs to the handler arguments, right? A3, B2. So get all these arguments from the user input into the handler function. So everything works just as expected. And this is basically tool calling, right? So this is tool calling. It doesn't need to have AI. This is tool calling already. All right. And that is the end of the first file. I think by 10 p.m., we're just going to finish up to like the second file. But that's okay as well. All right. Yeah, so that's the end of the first file. So we can see a tool calling. It's just a set of tools adding to registry, and then you have a user input where you call the tool name. You have these user inputs for the specific handler of the tool, and then find the tool in the map, and then run the tool, get the output, print it to the terminal. So that is tool calling. Okay. Now we're going to look at the second file, part 2 reasoning loop. And now this is where we involve AI. So a lot of times, right, when we think of AI, we need to think of it as the brain. We only use AI when there is reasoning needed. So a brain, right, basically, a brain is used to reason. A brain is used to think through an answer, think about a question. And so when a user prompt is ambiguous, when the user doesn't know what to use, so that is where reasoning is required. We use an LLM to look through the different tools in the registry and find the best tool for the user prompt. Okay, let me look at the README file, see if there's anything. Oh, okay. Yeah, so before we continue in the second file, I'll just go to the README file. README file module 2, line 74. Right, so this is where we introduce the React reasoning loop. So React basically means reason and execute. Reason and act. Reason and act. So this is a standard framework for agentic AI. And it's really common sense. Like to ensure the output is correct, ensure it's of the highest quality, definitely, we need the LM to reason first. Think before you act. Think twice, right? So React reasoning. And so, just like what its name suggests, it is a loop, not a single call. the LM will think through its answer. Right, so the two calls, right, they will appear in the API response in the form of an array. So there may be more than one tool call. And also to warn the user, let the user know what tools the LM is calling, right? So this this message, right? These are all standard protocol. Make sure that the user knows that this is a tool that the LM is calling. All right, we'll look through this in the file later. And then after this is a basic overview of what this React reasoning loop involves. So first, we have a user prompt, right? And we send this to the LM. And definitely also, if there was like this chat history, previous prompts, then there's also the history sent to the LM. And then the LM will reply with two calls, right? So there could be more than one tool call. So depending on the user prompt, the user may want to, or the user may not even know it, but then like there may be different tools needed to perform the user prompt. So more than one tool call is called and then execute all the tools. And then append the outputs, right, the tool results into the chat history. And there's something called the system message as well. Okay. And again, depending on the user prompt as well, if there's no tool call, then there's no output from the tools, then it's just text. So return text to a final answer. Okay, I will go back to the second file. All right, so just further information as well. Definitely for a loop to function, right, we have to add messages to the loop. Because it's a loop, it will just keep on iterating and see what is the best tool. So the LM will add messages into an array. And this array is also important for observability. The user can then know what went on inside the LM's thinking. So this will also form the chat history along the way. And also results are also the messages stored inside this array and form the bigger context. And again, as mentioned also, there could be more than one tool call needed to perform the user prompt that the user inputted. And same thing as well, handle errors. And then definitely also normal tool calls then can stop the LLM from continuing. Okay. So definitely before we even do a React loop, we need to initialize the LLM client. So we're going to use an OpenAI SDK compatible LLM. So FYI as well, in case if you didn't know, OpenAI is like the OpenAI's SDK, the framework, is the industry standard for many model providers. They use OpenAI's API endpoint for connecting to end users. So that's why we call it OpenAI compatible API endpoint. And so this OpenAI SDK is also used by Anthropic, Mistral. They are all called OpenAI compatible LLMs. So you can use the same API endpoint for different models, even though it's not OpenAI model. So we'll import this. We'll import the SDK. Oh, okay, sorry. I think in this particular case, okay, it's still pointing to OpenAI model. Okay, I will change this later. Okay, and then same thing again from the types TS file. So we define our data structures inside this types file. And these are different from the data registry. This is different from the registry, different from the tool definition. So when we work with an LLM, there are some more data structures that we will define. And we will look through them now. Inside this types file, so below, right, the first parts, they are all for the previous file, for the tool definition, for the registry. Okay, we'll look at the user message. Right, system message, tool result message, tool call. Yeah, we start with tool call. Right, so this tool call structure is used for the LLM to match to specific tools. Yep, so this is how the LLM actually uses the tools that we have in the registry. So every single tool to the LLM, there's an ID. And then definitely, again, we are following the tool definition structure. For many tools, right, there is a type and the function property, right? And then we also pass this in to the tool call structure as well. So this will be used by the LM for the tool calling. Again, don't need to memorize this. Just understand the whole flow of this. Tool call, again, right, is used by the LM, right, for matching the results to calls. Right, so to know which tool it needs to call. Right, the most important thing is the ID. It will use the ID to identify the specific tool that it needs to call. Okay, and then after this tool call, we have a specific structure for user message. So this is the user prompt that is sent to the LM. And it's just really simple. Two properties, role and content. Role user, this is fixed already. So as you can see, there's no type definition. It's just the value user. And then content, right? So it's a type string. So content is the prompt that we're going to put into the LM. And we call this structure user message. And then we have messages coming from the LM. So besides the output from the tools called by the LM, there will also be messages sent by the LM. So like how we use like ChatGPT in daily life as well, like or other LMs of our choice, right? There are also these messages, right, that tell us about the LM's thinking process or the LM's any other kind of like comments on the outputs of the tools. So we have a particular structure for these messages coming from the LLM, right? So message generated by the LLM. So same thing as well, to make it more universal with like the user message, we have like similar properties. So this one role user, right, for user message. For messages coming from the LLM, we will call it role assistant. And then property content, same thing, it's string. And this one basically or. So it can be a string or null value, right? There may not be any messages coming from the LLM as well. But definitely user message cannot be null because we need to prompt the LLM. So it has to be a string, role, content, and then two calls. And so this is the array of all the tools the LLM would call. We store this inside a system message. So when the LLM messages like gets back to the user, the LLM will also tell the user what are the tools that it is calling. So there's a question mark here also, two calls question, because there may also not be any two calls. So in case there are two calls, then only there will be this property. If there are no two calls, then this property is optional. So that's the meaning of the question mark here. Okay, and then once we have the structure, data structure for our prompts, the data structure for the LLM's messages, we also have the messages for the tools. Okay, at this point, I won't go through anything more because there are different structures involved when it comes to tool calling for the structure to be defined so that the LLM can process everything clearly, but just like encoding as well, right? The different syntax and structures. So I'll stop here for this file because there's like 1, 2, 3. Yeah, never mind. So we can go through this on our own after this workshop. But just to know that there's always this data structure for different types of the data that we input or output, right? So just like any program as well, we need to define the structures. So back to the reasoning loop. How? So we input all these data types into this file where we import them so that we can also define the structures following these data types that we define in the types file. And we also import the tool registry because we'll also be using this registry to add the tools that we'll be using. And then we'll send this to the LLM to decide which tool to use. Okay, and this is the fun part. So this is where we initialize the client for the LLM. So again, async function, because we need to wait for the response. Call LLM. Okay, this one is using an OpenAI model, but depending on your model as well, just configure it, change it to your model of preference. This one is using OpenAI model and then model string, input the model name. Messages. So everything will be stored in an array of messages as what we saw in the data structures that we defined in the types file. And then registry, the registry that we imported. Okay, and then output will be a final message in LLM, right? Just like how we interact with LLMs, it will give like some summary overview. So promise of an assistant message. So for all OpenAI compatible models, you will see that the syntax is actually more or less the same. So it will be called .chat.completions. OpenAI, Anthropic, Mistral. I'm not sure about the Chinese models, but then for these compatible models, right, you'll see that they are all considered to be chat completions. And then we store the output of the LLM in so this will be the assistant message with us response, right? After that, we return the okay, there are some more operations. We get the message from the response, and then the message will be put inside the final message. But basically, we will get the output from the LM here, chat.completions.create, and then we input the user. We input the user prompt over here, right? So we call the API chat.completions.create. We start the chat, and then we want it to complete it, right? Give us an output, and this JSON here is the input, our user prompt. Definitely, we need to define the model we're using. Define the model, and also put in the user prompt. The user prompt will be stored inside this messages array. So this one will also be coming from somewhere else. And then when we call this function, it will input this messages array, and then we'll use this for the user prompt when we start the chat. So model, messages, and tools. Tools basically just get it from the registry. So notice something different here. Before that, in the previous tool calling, without the LLM, we need to tell the program clearly what tool we are using, right? So I just go back to the tool schema file. Right at the end here, right? When we want to execute a particular tool, the user already has to choose, calculate. The user needs to choose the tool. But then, what is the difference here? Now that we are using AI, AI forms the reasoning layer. We do need to choose the tool. The AI chooses the tool. So over here, in the third property of the input to the chat, we have tools. We just dump, like you can just think of it like dumping all the tools, right? Dump the entire registry into the LM, tell it to choose the tool, the best tool that matches the message of the user prompt, basically. Right, so dump the registry.get definitions as any, right? So this, I would say, it's just to make life easier for the program. So because it's a map, right, the registry. So we just get the definitions, turn it into an array as any. Okay, I forgot the meaning of as any, but then you get the array of all these tools from the registry, right? From map, turn into array, right? So this is also what we defined earlier, a class method, get definitions. Okay, cool. Yeah, you can see it as well. We defined earlier, return all definitions of the tools. So we dump the tools into the LLM. And then the output of the chat, right? So we are storing it inside response, right? Await. So basically, we are awaiting the answer from the LLM, store inside the response, right? So this is just the standard routine when we do something like this, API calls to third-party LLMs. Usually, it's always this kind of syntax, dot shadow completions, store inside response, const response, and then apparently the final message is stored inside a property in response called message. So we get the message from the response, response.choices, first item.message. All right. So do memorize this as well. Just understand the flow, right? We get the output, get the message of it, and then return the message. So notice that this is following the data structure of the assistant message that we defined earlier in the types file. So again, right, all these data structures that we are defining, they are all used to structure the inputs and outputs. So system message, row assistant, content, right, the message. Okay, apparently there's another property inside message. All right, so we're just going to follow the company's format, row, content, and then two calls, right? So if there are any two calls, right, then stored inside an array as toCall array, right? So this is basically telling us that this will be stored as an array of tocalls. And notice that also, it can also be undefined. And that's why we have the question mark earlier, tocalls question, right? That property inside the assistant message data type. And why is that so? There may not be tocalls needed as well. The user prompt may just be some simple chit chat with the LLM. So no tocalls, so undefined. And that's okay as well, right? We make sure it will not break the code. So a question mark. Okay, so assistant message type. Execute tocalls. And then at this point, we're just going to execute the tocalls. So before this, we call the LM to know the tools that it's going to call. And then once we know what tools are going to be called, we will execute them. So we write a function to execute the tocalls. So notice as well that we are only using the AI for the reasoning part. So in this React loop, right, the reasoning part is where the LM comes in. It will give this whole array of tools to be used. And that's it. That is where the LM comes and goes. We don't need AI in everything. We just need the AI to think. We just need the brain to think. But where the action happens, right, where the all this agentic thing happens, right, it's actually not really AI. It's more like automation, right? Automation is not AI. And so we have a function to execute the tools. So input the toCall array that we got from the LM into this function. We get the registry. Why? Because we need to find these tools inside the registry, right? All these tools that the LM returned to us, because they're all just names. Verbose Boolean. Oh, okay. Verbose is basically telling the function, depends on us. So we input true or false. If we want like more detailed output, then verbose. If not, then false. And then this one, it will return an array of all the messages from the tools. So tool result message array. And because it's async function, we are making a promise. So it promises that it will return this output, right? So it will take some time to return this output. All right. Okay. This is a very long return string, but then a return statement. Okay. I won't go through the whole thing. So just understand the flow of it, the structure. We get the tools and then we execute them. Right. So just go one by one, the tool calls, and then call the tool. All right. And then after we call the tools, right? Finally, we have one last function to, yep, this is the last function. Then we initialize the agent to use the tools. Okay, right. Yeah, so this is the execution part. And this is where we input the API key to our LM again. We're calling the LM again for this part. And this is where the structures that we saw earlier come in. Agent config, agent result. So in this case, I'm using Mistral. So as you can see, because it's OpenAI compatible, we're still using the OpenAI SDK, but then configure the API key to Mistral and then a base URL to Mistral's API endpoint. Okay, then just define max interactions. verbose. All right. So some typical configs. All right. So this is just to initialize the first conversation with the LLM. So see the conversation. So system prompt, basically some initial configuration for the LLM. Let the LLM know like its persona, like what it's supposed to do, the kind of like uh, person that it should be, how it interacts with you, and the tools. All right. Yeah, in fact, I think this particular function, so this is where it actually runs the tools. So previously, the tool call function here, the execution, this is more of listing out the tools and um, passing it into the agent later on. So this is listing out and then getting the messages from the individual tools, understanding what the tool is about. So in the end, we still need an agent to automate the running of all these tools. So we have uh, an initial array of the messages that we're going to store all other messages inside. And then we'll start also calling the tools for the agent. So at first, empty array. And after that, just keep adding the tool calls into this array. So this is for the context, for the chat history. And this is where we call the agent's LM. Right, so wait, call LM. Oh, wait. Oh, okay, sorry. Yeah, so it's actually using the function that we defined earlier, right? Call LM. This this function, this last function, run agent, it combines the previous two functions, right? Call LM, right, for the reasoning, and then for the execution of the tools, right? So call LM and the execute tool calls functions, they are both connected to each other in the last function, run agent. So it will call the LM for the reasoning, and then we will get an assistant message. And then along the way, there will be more messages stored inside the array of messages. Right, so error handling as well, no tool calls, then just return a string. Right, tool calls made. Yep, so this is the final function that consolidates everything, right? Calling the LM reasoning, and then there will be the execution of tools. And so store the tool calls made right inside the return message. Right, so over here, right? So in this final function, right, we run this agent, we have the reasoning part, we call the LM, and then we have the execution part, right? The act part, where it executes the tool calls. Right, so this is just the error handling part. So no tool calls that early, but it's also the same return structure after calling tools and executing them, which is over here. Yep. So we're just going to define a standard final answer for the agent when there is already no more two calls, or there's already like, because we define the max iterations, like, so to put a limit on our credits, API credits. So make sure that, yeah, it won't charge us further lah. So there will be a max iterations property defined. So just a standard answer. And then it will also return finally the two calls made. Yeah, so this run agent function, it combines the previous two functions together. Okay, I'm just going to edit a bit the OpenAI part to Mistral, and then I'll run this file and see how it all works together. Okay, just a few more minutes. I'm just going to stop sharing for a while. I'll change this to Mistral, and then everyone can see the output of this file. In the meantime, everyone can also like have a look through this file again. Think about what we went through earlier in this file and see if there's anything that you need to go through again. Anything to ask inside the chat function, just put it inside. Oh, Harish in the WhatsApp group. Okay. Wait, I'll just share the link to WhatsApp. All right. Okay, guys, just a few more moments before I can correct the environment variables to Mistral. Okay, guys, thanks for staying put. I'll just upload a video of the final part of this second file later on the WhatsApp. You guys can just check it out in the drive. Yeah, so I think there's some more like config errors inside. Yeah, I forgot to install and Mistral, by the way, so in the package. Yeah, so we need to have some more configuration first. Yeah, but I'll show you guys later on in the video recording. Okay, thanks so much, everyone. Bye bye.